Today we are on 4-1, classifying triangles. So this should be really easy review for you. We're going to classify triangles by their angles. So if all of the angles are less than 90 or acute, right, then it's called an acute triangle. If all the angles are equal to 60, it's called equiangular. If you have one angle greater than 90, an obtuse angle, then it's an obtuse triangle. If you have one angle that is 90, it's a right triangle. In your notes, you guys have pictures of what that could look like, so take a minute and look at that. So I think that makes sense. If all the angles are acute, it's called acute. If one of the angles is a right angle, it's called a right triangle. You can only have one angle greater than 90 in a triangle. You'll figure that out mathematically later, but that would be an obtuse angle, so it's an obtuse triangle. And then if all the angles are equal, 60, right, because 60 times 3 is 180, then it's an equiangular triangle. Okay, so now we're going to classify them by their sides. So if none of the sides are the same, it's called scalene. If at least two or more sides are the same, it's called isosceles. And if all the sides are the same, it's called equilateral. Again, you have pictures on your notes. I would look at those. Isosceles, typically we do this. Equilateral would look like that, and etc. Okay, let's just do some. Classify each triangle as acute, equiangular, obtuse, or right. So we are on number 19 in your notes. What are all of these angles called? They're all less than 90, therefore this is an acute triangle. 21. You try to figure out what kind this is. What kind of angle is 120? It's obtuse, right? So this is an obtuse triangle. Don't overthink it. Super easy. All right, here we go. If C is the midpoint of BD and E is the midpoint of line segment DF, classify each triangle as equilateral, isosceles, or scalene. So now we're classifying them by their sides, not the angles, okay? So let's mark what we know, things that may not be given to us yet. So C is the midpoint of BD, so that means C is exactly in the middle of BD, which means this and this are the same. Line segment BC is the same as line segment CD. So if this is 4, then this is 4. Okay, so we've taken care of that. E is the midpoint of DF, so that means this is the same as this. So if DE is 5, then EF is 5. Okay? So let's look at triangle AEF. Let's see where that one is. Right here it looks like AEF. So we have a side that's 5, we have a side that's 10, and we have a side that's, we don't know what it is, but it must not be the same as 10 or 5 because of the tick marks. So what kind of triangle doesn't have any of the sides the same? Scalene. Super easy. Triangle ABD this time. This is triangle ABD. Be very careful when you're looking at these, right? This is 8, which is the same as this one. They're both one tick mark, right? So they're both 8. Well, what's side BD though? 8. They're all the same, right? You have to be careful. So if they're all 8, then this is equilateral. Okay? Find x and the length of each side if the triangle FGH is an equilateral triangle. So they want x and each side. So I'm going to go ahead and say x is whatever, FG is whatever, HG is whatever, and FH is whatever, because they want all of that, and a lot of times you guys forget, okay? So if this is an equilateral triangle, what does that even mean? It means all the sides are the same. So these are all the same. So you could pick any two of those and set them equal. I went ahead and chose the 6x plus 1, and I set that equal to the 3x plus 10. You could have done anything else. You could have set this one equal to this one. You could have set this one equal to that one. It doesn't matter. Take a minute. Go ahead and solve for x, please. You should get x is 3. I went ahead and I subtracted 3x over, so I got 3x, and I subtracted 1 over, and I got 9. Divide by 3, x is 3. Okay? So we found x. but then they want the length of each side. Well, can't I plug it into each of the sides and figure it out? Is there a quicker way to do it though? If I plug it into one side, aren't they all supposed to be the same, right? So I'm going to go ahead and plug it into FH. It doesn't matter, but 6 times x plus 1 would be 18 plus 1, which is 19. So each side is 19. Anybody confused? If you are, ask a neighbor. Okay, find the measures of the sides of triangle XYZ and classify the triangle by its sides. So, excuse me, I would go ahead and draw the triangle. If you don't have graph paper, you can ask to pause really quickly and get a square graph paper. You can sketch it too because we're not going to be able to count these anyway. A sketch would be totally fine. It's up to you. So let's go to x, which is at negative 5, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sure you label that x. Y is at 2, 1, so write 2 up 1. And z is at negative 8, 3. 1, 2, 3, 4, 5, 6, 7. Oops. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 1, 2, 3. And here's z. So let's go ahead and draw our triangle. Ooh, draw yours better than mine. Okay, something like that. What I want you to notice here is we're not going to be able to count any of these. Okay, so we're going to need to find xy. We're going to need to find yz and xz. A graph is still helpful just to kind of get an idea on where to start, but probably you're not going to be able to count. So if I can't count and I want the length of each side, what am I probably going to use? The distance formula, right? So if I want the distance between x and y, I'm going to use my distance formula with x and y. Okay? If you've forgotten it, it's distance equals square root you guys probably do the x first. That's how I have it memorized. So yours is probably more like this. x2 minus x1 squared plus y2 minus y1 squared. You need to have that memorized at this point. So if we're finding the length of, we said xy first, let's go ahead and label it so we don't get confused. So x2 would be 2 minus x1 is negative 5. We'll deal with that later. y2 is 1 minus 9. Okay? Try not to use your calculator if you can help it. 2 negatives make a positive. That's going to be 7 squared plus negative 8 squared. What is 7 squared? It's going to be 49. What's negative 8 squared? Be very careful. It's going to be 64. So we end up with the square root of 113. So xy is the square root of 113. I'm going to leave it that way for right now. We'll do yz together, but then I'm going to have you do xz by yourself. So yz is these two. Okay, so that's 2, 1 and negative 8, 3. Let's go down here. So I'm finding the length of, what did I say, yz now? So x1, y1, x2, y2. Distance formula, x2 minus x1 is negative 8 minus 2 squared plus y2 minus y1, 3 minus 1 squared. What is negative 8 minus 2? It's going to be negative 10 squared plus 3 minus 1 is obviously 2 squared. What's negative 10 squared? It's positive 100. What's 2 squared? Just a 4. So the length of yz is the root of 104. You guys find xz really quickly. So xz is going to be, x was at negative 5, 9. And z was at negative 8, 3. So do your distance formula. I'm going to start filling stuff in while you're trying it, but I'm not going to talk. I want you to do it yourself. So you should get xz is the root of 45. If you don't, you could pause it and see what I did and just kind of watch, I guess, or ask me or a neighbor later. Excuse me. So this is root 45. Technically, we need to break these two down because we can. I'll do that in a second, but I'm not even going to see what those are as decimals. Are any of these the same? None of those are the same, right? You could change them to decimals if you want to. But because none of the sides are the same, what is that triangle called? Scalene. Okay? Let's break these down just because we should know how to do that by now. Square root of 104 is not broken down all the way yet. So the highest perfect square that goes into 104 evenly is 4, with 26 left over. Square root of 4 is 2, so it's really 2 root 26. Those are the same. Square root of 45, the highest perfect square that goes into it is 9, with 5 left over. Pull them apart. 3 root 5. You did not have to do that to understand the answer. It's just something that we need to stay in practice with. If you have any questions, let me know.